Hi everyone, this is Mr. Ang and we are now on the second video of household electricity. So in this video we're covering the 5 different safety features that protects us from electrical shocks. So the 5 features that you need to know: switch, fuse, circuit breaker, earthing, double insulation. Okay, so let's go through one by one, even though now it seems unfamiliar to you. Okay, first one, switches is probably familiar. They are designed to complete or break a circuit. You can switch on or switch off. Okay, they are always fitted to the live wire. This is what you need to take note. Okay, why I put it at the live wire is because the live wire is dangerous due to its high voltage. Okay, we'll talk about the different kinds of wire later, but you just need to know for now, the live wire is where the switch is. Alright? Second one is on fuses. Okay, fuses is probably something new that you have not heard before. What it does, it prevents a current that is larger than the required value from flowing through it. Okay, so it kind of like it's the person in charge to make sure that the current that's flowing through is not too high. So what does a fuse? It consists of a short, thin piece of wire, and it will melt when the current exceeds a certain value. Okay, so this is what a fuse looks like. It's very simple. It's just a cylinder, a very small cylinder, and inside there's this thin wire. So what happens when there's a large current flowing through? Okay, the thin wire will actually melt, and then you break the circuit. So when there's a hole, it melts and there's a hole, it becomes an open circuit. So that way, the electricity cannot flow anymore. So fuses come in many fuse ratings. From 0.5 here, you have 2, 16, 20, 4, 8, 16, 25. So it depends on what the appliance is requiring. You put the various fuse rating. Okay, so the maximum current a fuse can withstand before it melts is known as the fuse rating. So how much current you can take before it melts. So some of the common fuse ratings you need to know is 1 ampere, 2 ampere, 5, 10, and 13. Okay, how do we choose which one to use? So fuse ratings are generally slightly higher than the required current flowing in the circuit under normal use. So what do I mean by this? So if let's say I have a circuit and it requires 4 ampere, which fuse will I use? I will use a 5 ampere fuse, slightly higher, right? So if I use a 10 ampere, okay, it is still possible, it can work. However, it is not encouraged. Because if I use a 10 ampere, that means any current from 0 to 10 can flow through. And we don't want a current that is around 7 to flow in because it will damage the appliance. See, when the circuit only needs 4, if let's say allow 7 ampere to go in, it might destroy the circuit. So always choose a fuse rating that's just slightly higher than what is required. Okay, so here we have a table to help you have an idea. So I give you more examples. Let's say the current in the circuit is 0.5. I just slightly higher will be 1. So I will choose 1 because it's slightly higher than this. If the current inside is 1.5, from this list I probably choose 2 because it's slightly higher than 1.5. And same, if it's 3 ampere, I can't choose 2, so I have to choose 5. I wouldn't want to choose 10 or 13 because they're too high. Okay? Same for 4 ampere, I'll choose 5 also. Now for 5 ampere, I wouldn't want to choose a 5 ampere. Because if I put a 5 ampere fuse here, what's going to happen is it might just blow when I switch on the circuit because it will not work. Because the current in the circuit needs 5 ampere. So if I have a fuse that's 5 ampere, it will just melt. It will not work. Okay? So here, if it's 11, I'll probably choose 13. Okay, so this is regarding fuse ratings. The next thing you need to know for fuse is that it's always connected to the live wire. So this is just a very simple circuit example. So if the live wire is here, you want to put the fuse here, because this is where the high voltage is. So if the fuse here breaks, right, at least the high voltage it stays here. It doesn't go to your load is not at high voltage. That's why it will not be dangerous. Alright? So this is for fuse connected to live wire. Next, the third thing we need to know is circuit breakers. Okay, so circuit breakers are similar to fuse in that it prevents a current that's larger than the required value from flowing into the circuit. So this circuit breaker, instead of melting, it will break. There'll be a mechanism inside that actually breaks the circuit, so it becomes an open circuit. And so any current flowing that's too big, it will break. That way, you are protected from the large current. So a large current surge is dangerous, as it can cause damage to the electrical appliance and can overheat the wire and even start a fire. So that's why it's important that we make sure that large current doesn't flow through. That's why we either use a fuse or we use a circuit breaker. Now, just to make sure that you know how to do your worksheet, one of the things you need to take note of is a circuit breaker. Usually they have an electromagnet inside. So this one, you don't need to know the details yet. In the upper side, you will learn more. But for now, you just need to know there's an electromagnet that actually operates the circuit breaker. So it doesn't just melt in this case. It actually, there's a magnet inside. Okay, so what does a circuit breaker look like? So if you are especially if you stay in a HDB block, you'll see this near your door. So this is what we call a circuit breaker. So if you open it up, probably looks something like this. I got this off the internet. So you have many switches and probably one master switch at the corner. So this is where you go to if, let's say, your house, the electricity trip, you come to here and switch it on. Now, why does your electricity trip? Okay, most of the time it's because maybe there's a fault somewhere in your electrical appliance. So maybe it's not wise to just switch it on immediately, but to go and check where is the fault first before you come back to this and switch it on. So that's what a circuit breaker does. It saves you from large current to enter your house. Okay, so that is for circuit breaker. The fourth one is earthing. Now, if you have noticed your usual appliance, they have 3 pin. They have a 3-pin plug. So actually, the 3-pin plug, inside there are 3 different wires. Each wire has a different purpose. So the 3 wires, we call them live wire, neutral wire, and earth wire. And each of these wires has a different color to make sure that it's easy to recognize. So the live wire is brown, neutral is blue, earth is green and yellow. It's not just either or, it's yellow and green. Okay, you'll see that later. So you need to memorize this because this will usually come out in exams. You need to memorize the colors. Okay, so this is just an example of what a 3-pin plug look like if I open it up. So you see on the right side here, right, this is a fuse. And the fuse is connected to the live wire. Brown is the live wire. The neutral wire is blue in color. And the one that goes up, you see, is green and yellow. Okay, it's strips of green and yellow. So this is another picture to make it see better. So here your fuse rating is 13 ampere. You have a live wire, brown, neutral wire, blue, and your earth wire, green and yellow. Of course, you can't really see the green here, a bit here. Okay, usually you have this thing called a cord grip or a cable clamp, basically to clamp the cable inside so it doesn't slip. Okay, so this is for the 3-pin plug. Okay, here's a summary to help you remember. For live wire, we put a fuse and we put a switch there. Neutral wire, we don't usually connect it to anything. But for earth wire, we connect it to the metal casing. Why? Okay, so take note of this. So, okay, before we continue to talk about the earth wire, let's go through this part. The plug is then connected to a wall socket or power point. So when I switch on an appliance, the voltage and currents in the 3 pins are as follows. So the live wire is where the high voltage is. It is at 240 volts. Neutral pin is 0 volts. Earth wire of pin 0 volts. So only the live wire is at high voltage. So under normal working condition, the current will flow into the appliance through the live wire, so 10 ampere, and then go back to the wall through the neutral pin, 10 ampere. So under a normal working appliance, right, both the live and neutral wire will have current. The earth wire should not have any current. It is a safety feature. Okay, so what does earth wire do if it has no current? So this is just to show you what it looks like if, let's say, you have no earthing. Okay, the first part, if let's say there's no earthing, the live wire comes here, and let's say there's a fault. The live wire is broken, and it touches the metal casing. In this case, a washing machine. So if it touches the washing machine, the washing machine will have high voltage. So if you touch it, right, the current will flow through the washing machine, which is metal, and go through your body into the ground. So that's why it is dangerous, because the person touching the metal casing, a large current will flow through. This is without earthing. So what happens if you put an earth wire? You notice earth wire is now connected to the metal casing. So if I have a fault, now that the live wire again broken and touches the metal casing, the large current now flows through the earth wire, which has a lower resistance, and so the person doesn't suffer from an electric shock. So again, if you look through, here the current will flow here, go through the metal casing of the washing machine. Instead of flowing through the person, because this has high resistance, it actually goes through the earth wire here. It goes through the earth wire here, it goes to the earth, everyone is safe. The current flows in, flows out here. Okay, so the flow of the large current now creates a short circuit. So also, as you go through the earth wire, it creates a large current. So this fuse here will actually blow. So when this fuse blows, it's open circuit, large current stops flowing. So then you are safe. Okay, if you don't understand this whole part, you can just rewind and play again. Okay, if you still don't get it, you can come to class. We will go through in detail. Okay, so this is what it means in words. So there are 4 main points. First, the earth wire is connected to the metal casing. Okay, so when there is a fault, the live wire touches the metal casing, and the metal casing will be at large voltage. Okay, take note of that. Now, because it's at large voltage, there's a large current that will flow to the ground through the earth wire and blow the fuse. So this protects the user touching the metal casing from getting an electric shock. Okay, so this is kind of a summary of what I explained just now. So in exams or in questions, you probably need to learn how to answer this in a shorter way. Take note, just answer there's a fault where the live wire touches metal casing will be high voltage, and large current will flow through the earth wire. So that's the purpose of the earth wire. Okay, next, the last point, double insulation. So how does this double insulation work? So some appliances don't only have the 2-pin plug. So not all appliances have 3-pin. What that means is that there's no earth wire. There's live and neutral, but there's no earth wire. So in this case, usually they have double insulation to protect the user from the electric shocks. So in double insulation, the metal casing, other parts of metal are wrapped up in an insulating material, so that a user will not be able to make contact or basically touch the metal parts. So this is called double insulation. I have the metal parts actually inside, so deep inside that I cannot touch it. If I can't touch the metal parts, I will not get electric shock. So this is just a comic to help you have an understanding. So electrical appliances, hairdryer, fan, vacuum cleaner are common at home. Most of them have 2-pin plugs. So this is the label. Okay, so this is not very clear. So this is the same thing you have. So what is the double insulation? First layer, right, is where you have the wire actually around this. There's a insulation, there's a rubber tubing around it to protect you from the wires. And then plus the second layer of insulation comes from this container that's inside, that's covering your appliance. So for example, hair dryer. You realize your hair dryer on the whole of outside is plastic. There's no way you can touch the metal parts inside. Or maybe your radio or your TV. Okay, there's a plastic covering around the whole thing that protects you from the metal parts inside. This is called double insulation. Okay, so since there's double insulation, if there's an electric fault like the previous one, where the live wire touches the casing, this casing will not be live, because the casing here is a plastic casing. It doesn't conduct electricity. So if I touch it, I can be smiling. I won't be getting an electric shock. Okay, so we come to the end of double insulation. Just take note, the symbol is just 2 boxes. Okay, so if there's any questions, you can just always watch the video to help you understand better, or you can bring your questions to class. Alright, that's all for household electricity. Okay, we have come to the end also of the syllabus for this Sec 2. Okay, all the best for your common test as well as for your end of year exam. That's all.